let me pause it. On. Okay, we're starting it. So let's talk about timeline and implementation. Um, the first thing to say is that everything I'm talking about today is on the website. I'm not pulling this out of the air. It's all on the website. And I'm about to talk to you about the timeline for this program for Mission 21. Well, there's a page called the Mission 21 Critical Timeline, which is a bulleted list of all of the deadlines and milestones from program start all the way to getting your experiment back from space. And so it's all there. But let me give you the top level milestones to just kind of give you the landscape. So program operations started on September 2nd, which is 10 days ago. And what that technically means is it started a 9-week clock. And so the idea is that students have to come up to speed on the microgravity curriculum in that 9 weeks, design their experiments, and write their proposals and submit them at the end of 9 weeks, which is early November. At that point, your step one review board takes the proposals together. You do your thing, you select 3 finalists, you send them to us. We convene the national review board, and by December 19th, your flight experiment is selected. So you could put out a big press release just before the holidays. And then your flight team has 2 months to optimize their experiment, followed by 4 months of flight safety review at Johnson Space Center, which means the earliest the experiment can launch is early June, June 10th of 2026. But that is due to the toxicology timeline. We still need to get experiments on a rocket, and what rocket will be available depends on the schedule that NASA presents, and that schedule is always moving. So the best way to say this is that June 10th is the NET date, no earlier than. When it actually launches is out of our hands. It's critically dependent on the NASA launch schedule and how things proceed. So does everybody understand that timeline? Any questions about timeline? Okay,
Seems
now let's talk
straightforward.
about, I think somebody said something, Ishaya?
Timeline just seems straightforward to me.
Okay, cool. All right, sounds good. So now let's go
Also,
on to implementation. Now, this program is also done at the pre-college level, and the pre-college implementation is by definition different than the undergraduate implementation. There are 2 big differences that we have to appeal to. The first is that at the pre-college level, it's a minimum of 100 students, typically more like 300 students. At the undergraduate level, it's a minimum of 20, hopefully more like 30. And the second piece is that when you talk about undergraduate students should be expected to be self-directed learners. In other words, if you give undergraduate students a learning task, they should be able to do that on their own. And so the idea is that there are typically 2 separate implementations at the undergraduate level. And I think we have both models in the 2 institutions that are here. The first implementation is a recognition that there are many departments in a college that have students that could do this program. I'll give you one out of the ordinary example. If a college has students that are in coursework to allow them to become STEM teachers later, what a wonderful thing to invite those students into SSEP teams so that they could be immersed in an authentic research experience, which will make them better STEM teachers in the classroom. 75% of the experiments are biological in nature, so biology departments are important. So are physics and chemistry departments. And so one approach to implementation is an institution casts a large net, a wide net across the entire college. They say, hey, look at this program opportunity. Who's interested? And so you get students from across the college that participate. Another approach, and I think Shannon, you're taking this, is it could be a class, or it could be a classes that maybe focus on project-based authentic learning experiences, and you adapt SSEP for that semester, for that class. And so the students that are engaged are the students that register for the class. Shannon, did I get that right? But yeah,
Yeah,
go
that's
ahead.
exactly what we're doing.
But I think you're also casting a wider net as well to engage students that are beyond those classes.
Yeah, we do also have a club to yeah, to open up the opportunity to everyone else as well. Yeah.
And Pam, I think your approach is just casting the wide net. Is that correct?
Correct. So
Yeah. Yeah, so those are the two implementation approaches. So the way that this works, so when we take that into account and we say, well, how is the professional development for an undergraduate institution different than a pre-college institution? We obviously cannot train 300 students on the curriculum. And those students are typically not self-directed learners. So it's a train the trainers program pre-college. We train the teachers, and then the teachers deliver the curriculum in class to the students. And then the teachers do not say in their classrooms, hey, who wants to do this? And Sarah and Johnny are the only two that raise their hands, because I don't know how a teacher is going to deliver the microgravity curriculum to just 2 students and get to a minimum of 100 students engaged. So the way that it's done at the pre-college level is a teacher says, I'm going to do this with my entire class, maybe 30 students, delivers the curriculum to the students in class, and then breaks the students into formal research teams of 3 to 5 students per team. So that teacher could have 6 to 10 teams in the class, and that teacher is designated the teacher facilitator for those teams. Does everybody understand the pre-college approach to doing this? Okay. Now, let me also say at the pre-college level, once the students are engaged in experiment design and proposal writing, they have to do that in secrecy because it's a real research proposal competition. They're not talking to each other. And so that's why experiment design and proposal writing are done in out of class time at the pre-college level. So at the pre-college level, the curriculum is delivered as in class time, and the experiment design and proposal writing are done in out of class time, whether it's cubbies in the library after school or at lunchtime. So that's how it's done, say, at a high school. At the undergraduate level, as I said before, we expect students to be self-directed learners. The hope was that we could not only train faculty, but train all of the students that you have engaged in this program right now on this Zoom video conference. But I see we don't have many of the students here. So the burden is now on the instructors to get the microgravity curriculum to the students. And as I said, next week starts week number 3. Now, I think the saving grace to this is that this is all being recorded. The agenda is downloadable from the recordings page. You're going to have a library of 7 recordings on each of the topics on the agenda. So I think the homework assignment ought to be, okay, students, you need to read, you need to watch these videos and come up to speed on everything ASAP. And so, so that's, I think, the way that this needs to be done. So the idea is that students are going to be coming up to speed in out of class time, except though in Shannon's case, she's teaching a class on this. So the next aspect of this is that every one of your student teams is going to have to design their experiments and write their proposals in absolute secrecy. They can't talk to each other. And let me just explain the faculty involvement in this, how this works. So let's assume, for instance, that one of your teams says, hey, we want to understand the role of microgravity on planaria worm regeneration. Well, the first thing is that every team is going to need a faculty advisor. One faculty advisor could be a faculty advisor for more than one team, that's fine. But the faculty advisor serves in a generic capacity. The faculty advisor is herding cats in the sense that the faculty advisor should be an expert in experiment design, general experiment design, should be an expert in general proposal writing, And so if there are generic questions in experiment design and proposal writing, the faculty advisor is the go-to person for those teams with those questions. I should also tell you that via the contact button, we have an entire team over here to answer questions as well. So we have your backs. And if any question is submitted in writing via the contact button, it goes to the entire flight operations team, and they will know exactly who has to answer the question, which might be a toxicologist at NASA. And so the faculty advisor is the advisor for a team that provides generic background on a generic Q&A on experiment design and proposal writing, and should know backwards and forwards where all the resources are on the website. So if a team just has a question like, where do I find such and such, the faculty advisor can help. But every team is going to come up with a microgravity experiment in a science discipline of their choice. And so if that team is doing an experiment on planaria worm regeneration in space, they're going to have expert questions, expert level questions on planaria worm regeneration. And their faculty advisor is likely not a planaria worm regeneration expert. They need to get one of those experts, and we call that the researcher advisor for that team. Now, it may very well be that if a faculty advisor is an active researcher and they have a certain playground, they're experts in a certain playground, if the faculty advisor says, hey, this is my research playground, if you come up with an experiment in my playground, I can be your faculty advisor and your research advisor because I'm an expert in this playground. Does everybody get, I know it's a little complicated, but does that all make sense? Okay, so the faculty advisor and the researcher advisor could be one and the same person, but there's also a high probability that the disciplinary focus of the experiment is not an expertise on your campus. And maybe the faculty advisor could suggest somebody who is, or maybe the faculty advisor has no clue who to go to as a planaria worm regeneration expert. So on the website, it provides you an understanding of how each team can get a researcher advisor who's an expert in the focus of their discipline. And it's using Google Scholars search. So let me give you the concrete example. This team that's doing planaria worm regeneration needs a researcher advisor. So they put planaria worm regeneration in the search field in Google Scholar Search. And what are returned are scholarly peer-reviewed papers on planaria worm regeneration representing state-of-the-art human understanding in that discipline. We're not asking the students to read the paper, but to go to the top of page 1, where the authors are listed in their host institutions. And if Dr. Jane Smith is a co-author on that paper and she's at Harvard, the student team goes to the Harvard website, goes to the staff directory, gets Dr. Jane Smith's email address, and writes a really nicely worded email to Dr. Smith asking if she can be their researcher advisor. And if that email is a template, then they can go, the student team can go to many papers on planaria worm regeneration and send that email to 20 possible researcher advisors, and all they need is one to say yes. So does everybody understand the pathway to get a researcher advisor? And that takes the burden off of faculty advisors who are not experts in that discipline and don't want to be stressed out with questions that are expert level questions in a discipline they're not familiar with. Everybody good with how that works? So does anybody have any questions with regard to either the timeline or how the program is actually implemented at your institution?
I have a quick question about the faculty advisor. I kind of just assumed that I would be the faculty advisor for my classes, and now I want to double check if that's an appropriate assumption.
That's fine. So you're operating more like the teacher, the teacher in a high school classroom where your entire class is under your supervision, and you become the facilitator for all of those teams. So yeah, you can be a faculty advisor for all of those teams. But the only thing that you need to be careful of, and I'll give you a real world example. The Applied Physics Laboratory of Johns Hopkins was applying against, was submitting proposals against a NASA announcement for a Discovery class solar system exploration spacecraft. So it's a very expensive spacecraft. And NASA says, hey, propose something for solar system exploration. So one team is looking at a comet, another team is looking at the moons of Jupiter, what have you. Well, one thing that's really important for spacecraft is spacecraft navigation. So you need an astronavigation specialist, a researcher in astronavigation on your team. There were multiple teams at APL that were putting in proposals, and they could not talk to each other. If they talk to each other while they're putting their proposals in, they will be fired. It's that serious in the real world. But they needed an astronavigation expert, and APL only had one. So that expert was an expert for all of those teams, but that expert knew very, very, very deeply that whatever they said to one team could not be shared with another team. So if you are a faculty advisor for multiple teams, you need to make sure, you need to be aware that you have to put firewalls between your conversation with each of those teams. Does that make sense? Okay, any other questions?